Good morning, friends. Today I am taking some of the different problems related with the combined stresses. Taklo. Good morning, friends. So, in the last few lectures, we studied combined stresses, and that's why I am taking some of the different problems related with the combined stresses. Means this is last class about the combined stresses. I cover all varieties about the problems related with the combined stresses. So please note down today's first problem. A hollow rectangular imaginary pier is Here is 1.2 meter and 0.8 meter overall. The wall thickness being 150 mm. A vertical load at 150 kilonewton is transmitted in the vertical plane bisecting 1.2 meter side at an eccentricity of 100 mm from the geometric axis of the section. Calculate the maximum and minimum intensities in the section. So actually this problem is the question paper's problems. A hollow rectangular imaginary pier is 1.2 meters. Suppose this is 1200 mm. This is due to video capturing disturbance, so that may be cut. So but this is problem, and this is hollow area. This is here a hollow rectangular imaginary pier is 1.2 meter and 0.8 meter overall. The wall thickness 150 mm. This wall thickness is given 150 mm. A vertical load at 150 kilonewton is transmitted in a vertical plane bisecting. Bisecting means this is the plane 1.2 meters we are considering, and this is bisecting. So that's why we can consider, or I consider this P point is load points are on the x-axis axis. From the geometric axis, calculate the maximum and minimum intensities. So maximum and minimum because in the right hand side maximum is compressive bending stress is induced, in the left hand side tensile bending stress is induced, and as per our theory direct stresses is to be considered. So that's why first I calculate area equal to solid area minus hollow area. Solid area, consider this is total solid area and minus this hollow area. So that's why you will get this is 5,01,000. Now direct stress equal to, so we can put this is equal to and divided by answers. This is equal to 0.294 mega Pascal. Bending stress equal to plus minus M divided by Z's. This is P into E divided by I divided by Y, or P into E multiplied by Y divided by I. So that's why first we will calculate moment of inertia. Now moment of inertia, here's in this case solid moment of inertia minus hollow moment of inertia. Solid equal to we can consider BD cube divided by 12 because this centroid axis passing through the centers, and BD cube divided by 12. Now capital B equal to 800 mm, we can consider D equal to total depth divided by 12 minus B equal to, now this is 500 parallel to x axis, D equal to depth 900 cube divided by 12. 800 multiplied by 1200 cube divided by 12, 1.152 10 to the power 11 minus into 900 cube divided by 12, and this is 0.30375 10 to the power 11. Now 1.152 minus 37 equal to moment of inertia equal to 0.8483 10 to the power 10 mm raised to 4. Y equal to, now distance, because this is y axis. What we calculate, that is, this is moment of inertia about x axis, but we require this is moment of inertia about y axis, because this is x axis. So this is not correct, because this is x axis, because this load point and eccentricity, this is EY, this is not EX. So that's why I calculate this is equal to IYY equal to 1200 800 cube divided by 12 minus, instead of 900, 500 cube divided by 12. This is moment of inertia about y axis. So we can take that is common, 12, 1 divided by 12, 800 cube, 900 multiplied by 500. So this is easy. Multiplied by 800 cube minus 900 multiplied by 500 and also cube divided by 12. This is equal to 4.185 to 10 to the power. This is 10. That's why sigma b. Now y equal to this is 1.2 because this is 800 because in the right hand side compressive. So this distance is the extreme fiber from the neutral axis. In this case neutral axis is the neutral axis is yy. So that's why y max equal to 800 divided by 2. This is 400 and sigma b equal to or pb equal to plus minus p into e multiplied by y divided by I yy, and this is ey. P equal to load 150 kilonewtons multiplied by 1000, ey 100, 400, and this is 4.182 10 to the power 1 divided by answers multiplied by 150 multiplied by 1000 multiplied by 100 multiplied by 400. This is equal to 0. Plus minus 143 megapascal. Now maximum equal to, calculate the maximum. Maximum equal to, this is PO plus PB. PO direct stress 0.294 plus PB 0.143 equal to plus 294 0.437 megapascals, and this is compressive. And minimum equal to, because in the left hand side this is the tensile bending stress and this is positive compressive direct stress and this is negative 0.294 minus 143 0.151 megapascal. This is also compressive. This is the solutions of the first problem. So we consume very more times in this problem due to disturbance. Now next problems. Second problem, figure shows the sections of a short 200 mm by 200 mm I section column, I section column carrying an axial load W1 Newton at O and a load of W2 Newton at P in a direction parallel to that of W1. The stress at the left edge is left edge BC is 115 Newton per mm squares. Compressive and that at the right edge DE is 90 Newton per mm square. Compressive. Determine the magnitude of W1 and W2 take for the I section area equal to 3671 mm square and I equal to, means this is moment of inertia, 2.624 10 to the power 7 mm raised to 4. Section is given, H section BC DE 1 here's load point W and this is P W2. This distance equal to 150 mm and this distance 200 mm and this is 140. This distance is not important because we require this distance. This is Y max. So in this case, area is given and I sections is given, moment of inertia, means rest of the problem is easy. Solution, direct stress equal to P divided by area, load, because here are two loads, so that's why W1 plus W2 divided by 3671. This is first equation. And in the right hand side, M divided by Z, load divided by IYY, load equal to, this is load W2, eccentricity 150, and this distance Y max equal to, because this is 200, so that's why 200 divided by 2. Moment of inertia directly given 2.624 10 to the power 7. This is W2, this is plus minus 150 into 100 divided by 2.624 10 to the power 7. So we'll consider 150 divided by 2.624 divided by 10 to the power 4. This is equal to plus minus W2 5716. Is there any mistake? All right. No. BC. So that's why stress at BC means PO BC minus PB equal to 15. W1 plus W2 divided by 3671 minus W2 5716 equal to 15. This is third equation. And stress at DE equal to, this is equal to 90. So that's why we can write W1 plus W2 3671 plus W2 5716 equal to 90. Fourth equation. So I can write W1 plus W2 divided by 3671 minus, this is W2 5716. Because here two unknowns and this is one unknowns, so that's why for cancellations we change sign, multiplied by whole equation, second equations by negative, So this negative, this is positive, and this is negative. And this will get cancelled. Now this is 2W2 5716 equal to 75. W2 equal to W2 equal to 75 multiplied by 5716 multiplied by 2. This is 857 kilonewton. Now, how we can calculate the remaining portions? By any putting value of the in any equations. Suppose these equations, W1 plus W2 equal to 857 3671 minus W2 5716 equal to 15. This is 857. So, this equation is to be solved. 3671 multiplied by 5716 equal to 15, and this is 5716 W1 857 multiplied by minus W2 857 multiplied by 3671 equal to 15. Solve these equations, you will get W1. Otherwise, I will solve this equation. 15 multiplied by 5716 multiplied by 3671 divided by this is not divided by, this is equal to 314751 540. Now this is 5716 W1 plus 857 5716 minus these values. So by taking commons, because this 857 common, 857 multiplied by bracket 5716 minus 3671 bracket close, this is equal to minus 314751 540 divided by 5716. This is equal to 54. W1 equal to 54 kilonewton. I will check my answers. So something is wrong because my answers is different, but this method is correct. So I think mistake maybe happens in the calculations, but due to the limitations of the times, I will skip here. You try to solve these equations, you will get correct answers. So what may be the methods we use that is correct? So I think here's mistake maybe happens. Check these values. So I will skip. But, please check these problems. That's why I take next problems. This is third problem. A column section. A column section. Please check this. Answers is correct or not. A column sections 300 meter. No, sorry. 300 mm. External diameter. And 150 mm. Internal diameter, supports an axial load, supports an axial load of 2600 kilonewton and an eccentric load of at an eccentric load of P kilonewton. This is again P kilonewton. At an eccentricity of 400 mm. So in this section, yes, sections now. Sections is circular sections. If the compressive and tensile stresses, if the compressive and tensile stresses are not to exceed. Similar type of the last problem is sum of change in the rectangular sections. Now this is circular sections. 60 Newton per mm square respectively. Find the magnitude of the load P. In this problem, in this column, again two loads, 2600 kilonewton and another load. This is P kilonewton. Diameters, external diameters 305 155 and this distance equal to 400. Again, this is a complicated sum of complicated problem. Here you can draw. This is circular section. And this load point you can consider here, and this is kilonewton. Again, direct stress equal to plus P, area equal to area. Otherwise, we will calculate first area, pi by 4, 300 square, area equal to by pi divided by 4, 53,000 mm square. Direct stress equal to 26 plus P divided by B equal to, otherwise moment of inertia, pi by 64, capital D raised to 4, small d raised to 4, pi by 64, capital D, 300 raised to 4, 150 raised to 4. Pi divided by 64, 372, 7.5 or 37275, 10 to the power 8. Right, y equal to 150. That's why PB equal to now only one load, P into E equal to 400 multiplied by y equal to, this is 150 divided by 3.7275 10 to the power 8. PB equal to plus minus, and divided by answers multiplied by 400. This is equal to 10 to the power minus 4 means P divided by 16096 P. This is second equation. This is plus minus. Now this is 2600 plus P divided by 53014 plus, and this is P 16096 equal to 140 and divided by minus 140 compressive, and this is tensile. This is plus minus, so that's why, but change sign, this is negative and this is positive, this is positive, this will get cancelled. 2p 16096 equal to 200. Multiplied by 200 divided by 2. Is there any mistake? P into E 400 multiplied by 150. This answers also Newton. This is also check, but this method is correct. So I will stop here and we will continue if any chapters related with the combined third units. Otherwise we can start fourth unit. Thank you.